Welcome to another math problem of the week. For today, let's look at this interesting and challenging question regarding complex number. Suppose x not equals 1 and x to the power 11 is equals 1. We also find the value of the summation 3 over 1 plus xn plus x to the power of 2n, where n runs from 1 to 11. And the options are A, 11, B, 17, C, 21, and D, 22. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
Since x not equals 1 and x power 11 equals 1, it means that x is not a real number. In order to get this summation, some will ignore the fact that x not equals to 1 and think that the answer will be just the same when x equals to 1. So they just simply plug in x equals 1 and therefore they think that this will equals to the summation 3 over 1 plus 1 plus 1, and that is a summation 3 over 3, so it's a summation of 1. And since n runs from 1 to 11, and therefore they think the answer is 11. Some of them choose the answer as A, 11. Unfortunately, this is not the correct answer. However, we can write this summation as 3, 1 plus xn plus x2n run from n equals 1 to 10. And for n equals to 11, then we see that this is 3, 1 plus 1 plus 1. This is the summation n equals to 1 to 10, 3 over 1 plus xn plus x2n plus 1. Okay. Now let's focus on this summation from n equals 1 to 10. We recall that u power 3 minus 1 can be written as u minus 1, u squared plus u plus 1. So this means that 1 over u squared plus u plus 1 can be written as u minus 1 over u power 3 minus 1. If we treat xn as u, then this can be written as 3 xn minus 1 over x3n minus 1, where n runs from 1 to 10. Note that x to the power 11 equals 1, so it means that x to the power of 11n also equals 1 for all integer n 1, 2, 3 up to 10. And therefore, this can be written as 3 x to the power of 12n minus 1 over x3n minus 1. x12n minus 1 can be factorized as x6n plus 1 and x6n minus 1. Use same formula, a squared minus b squared equals to a plus b, a minus b. It can be further simplified as 3 x6n plus 1, x3n plus 1. The x3n minus 1 will be cancelled off. Let's continue from here. So this will further means that its summation n equals 1 to 10, 3, 1 plus x3n plus x6n plus x9n. We can take out the 3, and this is summation n equals 1 to 10, 1 plus x3n, x6n, and x9n. Instead of the summation from n equals 1 to 10, we change it to the summation n equals 1 to 11. And of course, we need to minus 3 times 4, that is 12 here. Now, let's consider the summation x to the power of 3n when n equals 1 to 11. This is just a geometric sum where the first term is x to the power of 3. Using the formula, it will be a 1 minus rn over 1 minus r. So a is equal to x power 3. 1 minus r is also x power 3 In this case, there's 11 of them over 1 minus r. Now, x to the power of 11 is equal to 1. X to the power of 33 also equals to 1. And therefore, this sum is equal to 0. Using the similar argument, then we also have the summation x6n, n equals 1 to 11, and the summation x9n, n equals 1 to 11, both are also equal to 0. So with this result, then we can easily calculate the sum is 3. For summation 1, it will be 11. The rest of the summation will be just 0. Then minus 12. So this is 33 minus 12. So it's 21. So now we have the summation is equals to 21. Therefore, the answer should be 21 plus 1. Don't forget the plus 1, and it should be 22. The answer for this question is D, 22. For now, let's look at other people's solution. That's all for today's lesson. I'll see you again next time. Bye bye.